Welcome to Timber&Terra. I'm Glenn. I have my portable power pack, a vacuum cleaner. You can probably guess what I'm doing, which is sucking the pull cord through the 500 feet of conduit pipe that we just laid in the last 3 or 4 videos. So in here I have the vacuum cleaner. I have a bag and a shirt there to sort of cover up that suction so that the suction happens from up there, which is just this side of the excavator, which is the 500-foot point, and the midpoint vault where my trusted wife is sitting there ready to feed the cord and the plastic bag in the pipe. Well, that first one went well. First 500 feet, which is to the town road. Now we're at the end. This is the transformer vault where the transformer will sit, and we have another 500 feet from here to the midpoint vault. So in the garage, we are going to build a pedestal, and the pedestal is to hold this 2-socket meter, or 2-meter socket, whatever the proper term is. So this was spec'd out by my electrician. The electric company doesn't care so much about downstream of the transformer because they don't own it, but I do need to meet electrical code and pass the electrical inspector's requirement, so I'm working with an electrician who's given me some guidance on what to purchase. He spec'd this out, as well as spec'ing out the cord, or the line, the cable, aluminum cable. So this is a 400 amp box, but I'm only going to use 300 amps of it. In fact, I think each of these breakers is going to be 150 each for each of these meter sockets. That'll be 150, which is I think all I need for a power or current capacity, 240 volts to each of the potential cabins. We're gonna build one cabin for sure, and the second one if the first one works out okay, but I'm making provisions for both here on this. So I have a 12-foot 4x4. There are some requirements or guidance really that the electric company provides for these pedestals. The posts have to be at least 4 feet in the ground. Need to have this sleeve, which accounts for relative movement between the conduit and what the conduit is mounted to, which is that box. So this slides in and out, and you can see there's some goo there. There's some O-rings in there that provide a watertight seal and allow it to open, expand and contract. That has to be 16 inches above grade. The center of that box needs to be 5 feet above grade. So that gives me plenty of room. A 10-foot one was not going to work, so I got a 12-foot. I may end up cutting a little bit off the top. We'll see. I have some boards here from a project that I dismantled, some pressure-treated 5/4 decking. That'll work well for the sort of the backboard to mount that to. So the first thing then is to figure out exactly how wide I want that and how many boards I need to cut at that length to build our backboard. So we'll come back when that is underway. All right, so I've got this laid out. Here's the ground level, so it's just a couple inches more than 4 feet to make sure I have that minimum. The top board I have so that the top mounting hole is centered. top mounting hole, meaning that. In the bottom, I just should have plenty of room for the conduit, which will come out there. I decided to have this 32 inches wide, 1 inch overlap on each side, and then I'll figure out later if I want to cut any of this off. I'm going to treat the top one way or the other. Treat it meaning I'm just going to cut it at an angle so that it's not flat. One, it'll look better, and the other, more of a chance to wash off the rain. So here are some of the specs that I've been going by. So this is the particular case of, this is multiple meters pedestals, but it has some numbers on here that the other doesn't. This shows if you had a transformer mounted on the pole and you're going underground secondary to the meter, that's what this would look like. So that's 24 inches minimum instead of 36 for primary. I need 2 ground rods. They have to be a minimum of 6 feet apart, and that will ground that the meter box. Above grade, it has to be schedule 80 PVC instead of schedule 40. There's the slip joint that I showed you a bit ago. The minimum of 4 feet depth for the posts. This is more of our installation. Granted, it'll be a bigger box here than just a single meter. But here's the vault, which already has the ground rods there. Schedule 40 pipe is okay underground. There's the 2 feet. Schedule 80 right there above ground, the slip joint. Here's that same 6 foot minimum for the 2 ground rods connected with the cable. Talks about the pressure treated 4x4s and the minimum of 1 inch treated backboards, which is what I have. So this is the meter box for those that are interested in electrical stuff. You can use this sticker, or you can just follow where these bars are connected to. The top one is neutral. These two are hot, whether it's A, B, or BA, it doesn't matter. One will provide one leg of the 120, one provides the other leg of the 120. If you connect them together, that's the 240 volts for like a water heater, an electric range, a well pump. Or if you go from either of these legs to neutral, it'll be the 120 volts for most of the electrical loads that we're used to in a house. So you can look at this. This bus bar is connected here. This will be a for the neutral or the ground. So this is connected to this central here, to the meter, to both of them. One of these hots, this one is connected to this bus bar, which goes to the red one, which goes to the red one. That's the line side, or the power company side. This other one here will go to the breaker terminal, which is not connected to this, so that the current is going through the meter. That's how they measure how much you use. That one goes to the meter. This side is connected to this bus bar. You can see the bus bar there, connected to this one. Again, only to the red, which is the power company side. These naked clips or connectors are connected to, this one goes underneath and up to this one. So those terminals there will somehow connect to these breakers, which I did take apart and look. It wasn't obvious to me, but I'll get some help with that, the 150 amp breakers. So out of the bottom, one side will be for the coming from the transformer, and the other side, I don't know, maybe it has to come through here. Because this is blocked off, and this will be the metered side or the side going to the residence. I'm guessing it must have to go through one of these rather than over here, because there is no spot for it to pass through. So I'm guessing they have this sort of isolation wall for a reason, which I don't fully understand right now. These were probably made for like a 5/16 or perhaps a 3/8. I had some 7/16 grade 5 bolts little laying around, so I decided to use those. So evidently, 7/16 bolts are one of those where the bolt wrench size is different than the nut wrench size. So 5/8 for the bolt, 11/16 for the nut. I don't know why. So I had to cheat the box down a little bit because if I had centered the holes on that top board, which is what my plan was, then this would have been like right there in the seam. So I moved it down so I had a decent amount of wood to bite into. So another question I need to ask my electrician is, this is 2.5-inch conduit, so I need to, I guess it's that first ring in addition to the center. So that'll fit in there fine, but I'm pretty sure it's 2.5-inch conduit going from the meter box to the residence, and none of these are big enough. So I don't know, it just seems odd. So I'm not sure it matters which hole. I'll go to this one in the event that for some reason this one can be used to go to the residence. So we'll knock out this one. Graceful way to do this, but I don't know. Just in there. That's called the locking ring. I may tighten that up after I cement the conduit in there, and then this, I think it's just a bushing. I guess it's just a. Well, I guess it doesn't apply much for PVC, but it just provides a nice edge, I believe. Its only purpose just to provide a nice edge for the cable to go through here without getting chafed, the insulation getting chafed. Well, rather than wait and then me to forget to do it, I might as well just tighten this up now. That works. So for this conduit strap, holder, clamp to work, I'm going to have to provide something there. 2 1/4. So that should work. Not that like that. So I just had a 4x4 pressure treated that I cut back to 2 1/4 thick on the table saw. This expansion joint is 16 inches ground levels here, so they don't specify 16 inches to the bottom or to the center. Okay, well I think we're ready to take this out and dig a hole and put it in. I tacked this on just as a place to wrap some chains around here and here so I can lift it up with the excavator. Worry about putting the face plates on and the other stuff on afterwards. I attached my permit, so we're good to go there. So this is the transformer vault And at the suggestion of my my contact with the electric company, the field engineer, I guess you might call him, he suggested, because we might extend this for additional units back towards the woods over there, he said if you ever have any thoughts of extending the primary and putting another transformer in, say 100 feet further, he suggested putting one length of conduit in there, because that will avoid having to dig into a live primary vault. So that's what I plan to do. Is it's going to put a single length of pipe that would be a future primary just underneath that hole, underneath that ground wire. It's a very poor location for a big rock. As far as the conduit, I taped both ends. This end here. And I'll put this here at the end, just so if and when I do dig it up, hopefully it's obvious as to what this is, so I can hit this before I hit the conduit. So as far as the trench itself goes, I'm not going to line it with sand like I did the others. I'm just going to make sure that I don't have any big rocks. I think they say ideally less than an inch. So even ones like this are a bit too big. But I should be able to do that. Then I'm going to bend this, because I'm 3.5 feet there, but probably only 30 inches here. I'm going to set the bucket on top of here, bend this little bit, and I'll just fill it in enough by hand so that the conduit stays put, and then I'll finish filling it in with the excavator. Plus, filling it by hand, I can make sure I don't have any big rocks in there. So, just so no one wonders what this unused conduit is for, I'll write on there, future primary extension, EXT, and I'll put 10 feet. I know there's no buried electrical yet, but there could be. I don't think there's any harm in putting this down now. okay with filming for now? So that's the difference between schedule 40 on the right, schedule 80 on the left. Not a huge difference in wall thickness, but it is noticeable. The outside diameters are the same. It's the inside diameters. They're a little bit smaller with a heavier wall. This is that slip joint. I pulled it out and I noticed this black line. I'm guessing that's where you're supposed to put the black line, so it basically has equal distance to contract or expand. Makes sense to put it this way so you don't have water getting a chance to go in there, so I'll glue it up there. So the 3 lines here, I pushed through the conduit. They push really easy. It's that aluminum actually is pretty easy to work with. Pushed it in so it's just below the top of that elbow. I thought it would be easier to put it in here, have the excess in the vault before I glued that up. Then I should be able to push it in and just push it up through here, so later I can make the connections up here. Well, it's the next morning. It's very windy, so I apologize for the noise. I was able to get 2 two of them out easy. The third one, I didn't realize, but in there was enough of a lip where the third one was catching on it. So with the pry bar, I was able to move that away with my wife pushing on the other end, and we got all three out. So I have pulled them out. You can see there's a lot of extra there inside the vault here. Because this conduit goes in a little bit further, I want to make sure they have plenty of cable to connect to the transformer. So I'm going to cut this conduit back to, say, right here, and then push the cable through so we can connect it into the meter box. So this paint was starting to scrape off. So that's the neutral, that goes up here, and then the other two, phase A and B, it doesn't matter which, go here and here. So now we have some hardware to put in, as well as install the breakers. I tried the smaller lug opening and it would not fit, so I guess this is the one. So this is the neutral, and it needs to be white. For whatever reason, in this size cable, they don't make different color casings or insulation, so I'm going to have to get some either white electrical tape or white duct tape or something and just wrap it around here. Nothing, doesn't have to be fancy, just clearly identified as the neutral, and these two will be the hots. So it's a much less windy day today, and we're going to install these 150 amp breakers. So instead of this insulation thing, I'm not sure what the difference is, there's this insulation thing. And that actually mounts down here. So on the feed side, these get taken off. They're not needed because there's no cables to clamp. They mount here to these studs. On this side, everything stays intact because you stick the cable in there and then clamp it down. So these come out. These little screws come out, little flathead screws. A little help. I did put a little dielectric grease on there. No, it's recommended for aluminum. I think this is all steel, but can't hurt. So that's sort of loosely there. Now we got to put this in and figure out which one of these holes in the back that this screw should go to. It's tight. For these, so I guess, I just ordered this as a complete unit. They assume you're gonna connect both meters. I don't plan to connect both meters initially, so I really didn't need both breakers, at least yet, but that's fine. Just plan on at least the one unit and go from there on the second one. I just don't feel like working in the rain, and it may not be the best thing for electrical stuff inside the cabinet to work in the rain either. So in older versions of meters, I think the only way to disconnect power to the main breaker panel in the house was to pull the meter out. You know, basically just use this as sort of a disconnect and pull the meter out. Now they have these breakers. Guess it makes it easier. Done for now. We'll pick it up. We got to put the ground wire in, connect it in here, and I think we're basically ready for an inspection. Well, a subcontractor for the power company was here yesterday and installed the transformer and 1 meter. All zeros. So evidently everything went fine. Interesting that they have a lock here they didn't put in, so we can take a peek inside. Never really looked at one of these before. Keep out. Alright, I won't go in. So this line here with the red on it, it says from V2. I'm not sure what V2 means, but that's the primary. So that's what they ran in the conduit that we laid down. And then over here is the secondary, the 2 blacks, and then the white neutral. And you can see the ground here from the primary is connected to the neutral. And then the two wires right there are what I ran from the ground rods that are along this corner and that corner. They're buried now. And then the two ground rods there go into the meter panel. So interesting anyhow, so that's what that looks like. So this is the midpoint vault. They put the cover on, bolted it down, but there'll just be connections inside there. Obviously I need to do the landscaping, sort of fill in this. It's supposed to be exposed 4 inches from the ground. I still have to fill back there too, which I didn't mention, but hopefully it was obvious. I need to fill in around where I put the pedestal in and cover the conduit that goes to the meter box. That was left exposed for the electrical inspector. So you can see a little bit of settling here where the trench was. You can fill that in as well. Probably I'll finish this off next year. It's getting too late in the year to do much. You can see here the mud, which is probably not going to dry out this time of year. So there's a little bit of settling of the trench here along where we're walking. So we'll just review the pole and where the primary connects to the service along the road, and then we'll close things out. So another underground box. So I had installed the elbow up to here, and then they put this aluminum conduit on, which I don't know if I've ever noticed aluminum conduit on a pole before. I had always thought it was PVC. So what they added was that thing here that hangs out towards us. You can see the ground there goes to the second wire down. On the left hand side goes into the primary wire that runs down the conduit. On the right hand side is just the ground wire for the pole itself that goes to a ground rod down there. So then all that stuff up there, I don't know what all that is. I'm guessing part of that has to do with lightning arrestor. That piece there to the right is the fuse. So if something happens to my service here, it will blow that fuse rather than blow up some other fuse upstream of this primary supply, so other people don't lose their power. That's really it. So that finally finishes this project, other than a little bit of landscaping I have to do. But I'm glad to have that done. It's the first time I've ever put underground service in like that. It was quite a job, 1,000 feet and several videos. I appreciate you tagging along. Hopefully you've kept up with all the videos of installing this from start to finish. But it is in a playlist if you want to go back and look at those. So thanks for tagging along. I appreciate it, and I hope you'll join me for other videos.